Question 14. Which substance is used to reduce titanium chloride in the extraction of titanium metal? The answer is magnesium. A. However, it's now been taken off the syllabus, so that's unlikely to appear. Which statement about barium sulfate is correct? Barium sulfate is a white solid used in something called barium meals. So soluble barium compounds, it should say, react with sulfuric acid to make barium sulfate. So if you had something like barium chloride or barium nitrate, it would react with sulfuric acid to make barium sulfate. So barium sulfate is a white solid. It's used to test for barium compounds. Alternatively, you can get barium compound to test for sulfate. So if you had something like sodium sulfate reacting with barium chloride can be used to test for sulfate, sodium sulfate or potassium sulfate. It would make barium sulfate. Anyway, barium sulfate is an insoluble white solid, and it's actually used in barium meals. So you ingest it, you swallow a barium meal containing a suspension of barium sulfate as a solid. It should be toxic, barium should be toxic, but because it's insoluble, it doesn't dissolve in bodily fluid, it doesn't get into the bloodstream, and therefore it's not toxic. And it sort of sits in soft tissues, and because it's an insoluble solid, it can be used to x-ray soft tissues. Normally soft tissues would allow x-rays to go through, and so you couldn't x-ray a soft tissue, but the barium sulfate sits in the soft tissue, especially the gut and the intestine, and therefore you can x-ray for intestinal and gut problems. So your answer is B. Which statement is correct about the reaction between sulfuric acid and sodium bromide? Well, you need to know the equation. Concentrated sulfuric acid reacts with hydrogen bromide or sodium bromide, doesn't really matter, sodium bromide, sodium bromide, hydrogen bromide, and makes bromine, which is a brown solution, or sometimes orangey brown fumes, and sulfur dioxide, which is a choking gas. And if you think of sodium bromide or hydrogen bromide, hydrogen and sodium are both in group 1. They've got an oxidation state of +1, so the Br, the bromide is Br minus, -1 oxidation state. And if it goes to bromine, which is just an element, Br2, then that's oxidation state 0. So it's gone from -1 up to 0. It's been oxidized, so its oxidation state has gone up from -1 to 0, and so it's been oxidized. So the concentrated sulfuric acid is causing that oxidation. It's an oxidizing agent. So let's have a look. Bromine ions are reduced. No, they're oxidized. Hydrogen bromide and sulfur are formed. No, bromine and sulfur dioxide are formed. Sulfuric acid acts as the oxidizing agent. Yes, it causes the bromide to be oxidized into bromine. Bromine and hydrogen sulfide are formed. No, bromine is formed, but sulfur dioxide as a choking gas is formed, and not hydrogen sulfide, which would have the smell of bad eggs. So your answer is C. Which compound is used to treat the symptoms of indigestion? Well, acid indigestion. Indigestion is when you get acid in your stomach, and so you can need an alkali or a base. You can need a hydroxide. And it's actually magnesium hydroxide that's used in indigestion tablets. So hydroxide is a base or an alkali, reacts with acid indigestion. It's less soluble than calcium hydroxide, so it can be swallowed more easily as a tablet. B is used in indigestion tablets, magnesium hydroxide. Which element has the highest first ionization energy? Now, so as you go across the period from sodium to magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon, they tend to go up. That's no surprise, because as you go across the period, you're getting more and more protons, so you can get a greater nuclear charge. So attraction, a greater nuclear attraction for the electrons, the outer electrons, and so it needs more energy to remove the first electron from 1 mole of a gas. However, there's a few anomalies in there. So what happens is, because you get s and p orbitals, then that's 3s1 rather, 3s2, and this aluminium has got 3s2, 3p1, so that's removed from a p orbital. Now a p orbital is further from the nucleus than an s orbital, and therefore if it's further from the nucleus than an s orbital, that 3p1 electron is more easily removed, needs less energy to remove, because that p electron in a p orbital is further from the nucleus. Then you get 3p1, 3p2, 3p3. Now 3p3, a p orbital contains 6 electrons, so these 3p3, these 3p electrons in the p orbitals are not paired, whereas this one has p4. So it has 3 p electrons and a 4th p electron, and that forms a pair, and they repel. And that repulsion means that that 4th p electron is more easily removed, and that's why it comes down slightly. So your lowest one is not actually phosphorus, it's actually sulfur, because that comes down slightly. So your answer is the highest first ionization energy is phosphorus, because sulfur comes down slightly. So your highest first ionization energy is phosphorus, as it comes down slightly to sulfur, removing that 4th p electron that pairs with one of the p electrons here. So 3p3, all single, all not paired up, and the pair then repels, and the 4th electron is more easily removed. So P, phosphorus, has the highest first ionization energy. A solution at volume 500 centimeters cubed contains 150 grams of ammonia. What's the concentration? Well, we need to get this into decimeter cubed by dividing by 1,000. We need to turn this into moles using the MR of ammonia. So ammonia is NH3, MR is 14, add 1, so 14 for the nitrogens, 1 each for the hydrogens, 17. Moles is mass divided by MR. Mass is 150 grams divided by 17. You've got 8.82 moles of ammonia. Now my volume is 500 centimeter cubed. To get 500 centimeter cubed up into a large unit value of decimeter cubed, I divide by 1,000. 500 divided by, that should say 1,000, is 0.5 decimeter cubed. So concentration is moles 8.82 divided by 0.5, 17.64. My answer is D.